Hey guys, I'm going to talk about page 48 where we're starting a new topic about sinusoidal word problems. Now this can feel a little bit tricky, especially when we start out, but remember it's going to be very similar to what we just talked about in our last topic, which was writing equations based on the graph for sines and cosines. So you used to see the wave and we would use that DABC method, right, where we would dab and find the four aspects for the function and write an equation for that, okay? Very similar idea, except this time we've got a word problem rather than a graph. Now, if we start with this example, it says, suppose that a weight hanging from a spring is set in motion by an upward push. It takes 5 seconds for it to complete one cycle, moving from its equilibrium position to 8 centimeters above, then dropping 8 centimeters below, and finally returning to the equilibrium position. Now, just the question itself can seem a little bit overwhelming, so I'm going to take a short second. Let's just draw a quick picture of this. I have some hanging position, and there's a spring, and from it there's a weight hanging, and I'm just going to draw a little box as my weight, okay? So this box is set in motion by a push, okay? So originally it's hanging there, and I'm going to push it upwards, and it goes for 5 seconds to complete a cycle, but it goes 8 centimeters up, and it goes 8 centimeters down, okay? And kind of in the middle, I'm going to say is my equilibrium, or my balance point, my center point, okay? So they're saying this is a sinusoidal function. Guys, anything that cycles or repeats itself, we can model like this, all right? So really they want us to find a pattern and make a graph from this, okay? So this is my picture that I've drawn right now, and we need to come up with a graph for this. Okay, so tucking my diagram away for a second, let's try to make a graphical picture of this, okay? So here's kind of my graph line, right? X and Y axis. And my original point, I'm going to call that 0, where I'm kind of balanced, okay? And my weight's going to start out at 0, and when I push it, it's going to go up to 8, right? So this point is up at 8. It's going to have to come back down, downwards all the way to -8. And it'll turn back around and come back to the equilibrium point, which is 0, okay? Now, how long did it take me to do all of that? This point originally is 0, 0, my origin, and my ending point, it takes 5 seconds to complete the cycle, so this will be 5, 0. And you can kind of see already this is making a sine wave, okay? So, as tricky as this may seem, guys, all I've said is I bounced this weight. It's going to go up 8 to this point. It's going to come back down, pass through where it was originally, come all the way down here to -8, and then it'll go back to its resting position here at 0, okay? And this pattern, it might continue. You may want to put some dotted lines saying, hey, you know, it does continue on where it's going up and down. But this section is probably all the information that we need, okay? So let's see if we can come up with an equation using our DAB method, okay? So again, I'm going to use the same method, and we're going to start by trying to figure out what each of these components is. And we'll start with the D value as the first piece we want to figure out, okay? So starting with D, I can kind of say, hey, my D is a little bit in the middle right here. I've marked it in dotted yellow. And that's going to be at 0, okay? It is at that center line on the axis. It has not been moved up or down, okay? So after I've got D, I'm going to want to figure out A. All right, following my method, we've got D, now we're on A. So the A is my amplitude, or my vertical stretch, and we can look at our graph and see, hey, this has an amplitude right here of 8, it goes from 0 to 8, okay? And if you want to see it mathematically, you could say, hey, this is 8 minus 0 to figure out my amplitude. Now, once we've found those two, we have to figure out B. Now, B is a little bit trickier than D and A. D and A are very easily visible on the graph, or just by any picture, really. Now, B was a little bit tricky. In order to figure out B, we're going to need the period to help us figure this out, okay? So to find B, we have to remember that B is equal to our 2 pi divided by the period of your function, okay? You may see this formula written a little bit differently. You may see it as 2 pi divided by B is the period instead, okay? But those both mean the same thing, right? So let's think back at this situation. What is my period here? Well, I'm hoping that you got back to the problem and saw, hey, it takes 5 seconds for it to complete one cycle, all right? That is a pretty good hint that that's going to be my period, all right? So let's fill that in. It takes 5 seconds, so that's my period, and I've got 2 pi over the 5 seconds, and that's going to be my B value, 2 pi over 5. Okay. Okay, so that was our calculation for B. Let's kind of tuck that away for now. And let's go ahead and figure out what my C value will be. Now remember, C is going to depend a little bit on whether we know a sine function or a cosine function. All right, so in this case, I know that here's a maximum point and here's a minimum point, but I really don't know exactly where those happen. And maybe I could find a way to figure out those points, but it might just be simpler to start from the middle point, right? And the midpoint means that we're going to be making a sine function, okay? So you may want to remember midpoints always give us sine, and max value points can give us cosines, okay? But in this case, the point I really know is a midpoint. It is 0, 0. And I'm going to use that information to help me come up with this equation. So my phase shift, my C value, is actually 0 as well, just like the D. I'm starting from the origin, so I haven't moved left or right, I haven't moved up or down. So now we're going to try and put all of this information together, that A, B, C, D that we know, to write a sine equation for this, okay? So remember your format: A sine B, x minus C plus D, okay? And I just used capital letters so they show up better. You may have seen it written in lowercase, no big deal. So let's just plug in our numbers, okay? I'm gonna skip plugging in the zeros. These don't really need to be plugged in. So I've got 8 sine 2 pi over 5, that's my B. And there's no C value, so we'll just say X. And there's no D value, okay? So this is my equation right here. All right, so that seems like a lot, guys. We took a lot of time to draw a picture and especially make that little graph as best we could, right? All I knew that was that it started at 0, 0 and it took 5 seconds to go up and down, okay? But I was able to come up with some kind of point even though I didn't know where the exact values in the middle were. Now we've figured out what that equation is, all right? So that's actually parts A and B. We drew a graph. Even though it's not super pretty, we have a graph and we have an equation, all right? So the question is, what can we do next, right? What about part C and part D? And just trying to see what else we can do here. So I'm gonna put this aside. Let's just remember our equation and we can look at what's going on in part C and part D. Now, I kind of pushed it aside, but if you look at your book, you can see that part C is actually asking you for predicting the height after 3 seconds, okay? So to do part C, I would take my equation and I would just plug in 3 for my x value. And if I simplify this a little bit, you're going to realize that this is 6 pi over 5. And you get kind of stuck. You would want to be able to solve this using your unit circle, but this value, 5 pi over 6, isn't actually on the unit circle, which makes my life very difficult. And so I kind of just have to stop here, okay? You would need a calculator of some kind for this, and if you don't have a calculator, this is kind of where you stop. But by plugging in 3, you've actually predicted the value for the height at this time. Okay, so that was part C. Part D is very similar actually, except part D is just asking us, can we, instead of trying to figure out the height based on the time, where we know the time or the x value, can we figure out the x given the y value, which is the height? So in this case, you're just going to set the same equation up, except we're going to have your 6 for y, okay? So just a note that that is my y value. All right, and the thing is, again, we're kind of stuck here. We can't solve this without a calculator pretty much. We're going to work our way backwards. We would divide by 8, and then we would use an inverse trig function. But again, we kind of have to stop. We don't have a calculator to do this, okay? A lot of people would plug this into their calculators and look at the graph, and then just see where the graph hits 6, and you'd be like, oh, that's my intersection, and that would be my solution for this, okay? So just want to backtrack for a second and look at the original work we did and see that our process is very similar to our problems previously, okay? We drew a graph, right? Based on whatever information I could figure out. I knew that, hey, my box starts out at 0, and I flick it, it goes up to 8. It comes back down, goes to -8, and then comes back to 0. And that took me 5 seconds. And I just made a wave, and as long as I got it close to the right shape, I was able to use that information to create the D, A, B, and C values and write the equation. Okay? That's basically the gist of sinusoidal word problems. Now, I know that we would hope that, hey, I want to be able to solve something like C, but unless you get a number that's on the unit circle, you need a calculator to do it. So if you had a calculator, you could type in exactly that equation and get some number spit out for you. If you're curious, you can put that in the calculator, and you should get, I believe that you get -4.702 as the value for this equation, right? So if you would put it in the calculator and you got that, that's approximately what the number you want is.